Okay, I'm making a few changes to the assignment 1.6. Okay, throwing out some more problems. Okay, we said skip 6, skip 55 also, please. Skip 55. Skip 67, C and D. 67 has A, B, C, D. We're still going to do A and B, but skip C and D. Okay. So for 1.6, skip 6, 55, 67, C and D, but we're still going to do A and B. And I'll probably still end up doing that. Okay, so I was going to finish 1.6 today.
Can you go back to that real quick with the questions
And
that we're
then give you
skipping?
the quiz. Okay, 2 days for 1.7, 2 days for 1.8. Okay, so again, skip 6, 55, 67, C and D. And of course, I'm recording now, so it's on the video too. You can check that out later. Okay, so I'll lecture some more, and then after a certain amount of time, I'll stop and give you the quiz. Just like last time, I'll break you up into your breakout groups. But unlike last time, everybody's responsible for their own work. So everybody has to do all the problems, not just one or two or whatever. So everybody does their own, and you'll be graded individually from here on out. Okay. All right. So picking up from last time, I'm going to talk again about even and odd functions. So even and odd functions. So these are definitions. A function is called even if f of negative x is the same as f of x for all x. So whenever you plug in negative x, you get the same thing as if you had plugged in x. It's called an even function. And it has y-axis symmetry. Symmetry with respect to the y-axis. This is SYM. I'm abbreviating symmetry with SYM because it's too long to keep writing SYMMETRY. You may abbreviate symmetry with SYME also. Okay, a good example is y equals x squared. Y equals x squared is an even function, and it's very suggestive. As you can see, the exponent is even. As you might guess, x to the fourth is even, x to the sixth is even. Okay, but if you go strictly by the definition, there are some functions that are even by definition, but they don't look like this. I'll go over that in a second. But notice right here, right? What do you get when you plug in, let's say, 3? You get 9. What do you get when you plug in -3? You still get 9, right? So that's always going to be true for this function. So you have y-axis symmetry. So if you put like a mirror right on the y-axis, the left side and the right side are mirror images of each other. Okay. A trig example is the cosine function. The cosine function doesn't look like this, but by definition, it's even. The cosine of negative x from trig is always the same as the cosine of x. So for instance, if you were to punch out on your calculator cosine of 17 degrees and cosine of -17 degrees, they'd be the same. Or cosine, pi over 12, cosine of -pi over 12, they'd be exactly the same. So cosine is also an even function. Okay, an odd function. A function is called odd if f of negative x is equal to negative f of x for all x. So when you plug in the negative of a number, you always get the opposite of what you get for f of x. Okay? And a good example is y equals x cubed. There's an odd exponent. Okay, so as you might anticipate, x cubed, x to the 5th, x to the 7th, x to the 9th, they are odd functions. Okay? They exhibit what's called origin symmetry. Symmetry with respect to the origin. Okay, so for instance, right here, what do you get when you plug in 2? You get 8. What do you get when you plug in -2? You get -8, the exact opposite, right? And that's always going to happen. Okay, and you have symmetry with respect to the origin. So if I take a point and reflect across the origin like that, or a point over here, right? It shoots way up to over there. Okay, and that's something called an odd function. Okay. A trig example is the sine function. The sine of negative x is equal to negative sine of x as an odd function. Okay, so for instance, if you tried the sine of 12 degrees and the sine of -12 degrees, they'd be opposites of each other. Okay, or sine of 2 pi over 3 and sine of -2 pi over 3, they're opposites of each other. Okay. All right, so that's even and odd functions. And now they have some examples in the text. So let me show you the text right now. Okay, so let me make this disappear and go to some book examples. Okay, we can probably knock all these off. 51 through 54. Would you say it's even, odd, or neither? Okay, so for 51, 51 looks like you have symmetry with respect to the y-axis. Okay, so 51 is considered even. So you can write even for that one. 52. 52 also looks like it has symmetry with respect to the y-axis. Okay, so 52 is also even. 52 is even. 53, is there symmetry with respect to the y-axis? No, it isn't. The left and the right side are not mirror images of each other. And it's not odd either. Okay, so for instance, if I take this point and reflect across the origin, I'm supposed to have a point over here, but I don't. Okay, so 53 is neither. 53 is neither even nor odd. So unlike integers, which can be either even or odd, there's no choice, right? If I pick any integer like 57 or 26, it's either going to be even or odd. Not so for functions. Some are even, some are odd, some are neither. Okay, and 54 has origin symmetry, so it's considered an odd function. Okay, so if I take a point like this, it reflects over to there. If I take a point like that, it would reflect over there. Okay, so 54 is odd. It's not even. It is not symmetric with respect to the y-axis, right? You don't have a mirror image across the y-axis like that. Okay. So I just want to share with you that one. Okay, and now at the end, you have some word problems. So let's look at some of those, like 61. A rectangle has an area of 64 square meters. Express the perimeter of the rectangle as a function of the length x of one of the sides. Okay, so area 64, express the perimeter as a function of one of the sides called x. So I'll show you how to do that now. Okay. Okay, so area is 64. Okay, now I call this x, I'll call this y. Okay, to find the area, it's x times y, right? So that means x times y equals 64, right? Area of a rectangle is length times width. So x times y is 64. If I divide by x, y is 64 over x, right? Just go like this. Y equals 64 over x. All right, so I've expressed the sides of this rectangle as x by 64 over x. And now I use the formula for the perimeter. Perimeter is 2L plus 2W, 2 times the length, plus 2 times the width. Because there's a length here, another length here, a width here, and another width here. So I have 2x plus 2y, but y is 64 over x. So 2x plus 2 times 64 over x. And 2 times 64 is 128. So final answer is 2x plus 128 over x. So that's what I want. So this is my final answer. 2x plus 128 over x. Okay. Okay, 63. Express the surface area S of a cube as a function of its volume. Okay, so you're given the volume, find the surface area of a cube. Okay, so how do you do that? All right, so I've got myself a cube here. And I know the formula. The formula for the volume of a cube, if you have a side x, is x cubed. V is equal to x cubed, right? Length times width times height for a box in general, but they're all the same, x by x by x. So the volume is x times x times x, or x cubed, right? So what does that make x? If I take the cube root of both sides, right? Cube root, you have x equals cube root of v. X is equal to cube root of v. And now I want the surface area. I'll call it S for surface area. So surface area as a function of V. So if you're given a V, how do you write S, the surface area? Okay, so if you take a cube, how many faces are there in a cube? There are 6, front and back, left and right, top and bottom. They are all squares, right? So I basically have 6 squares to add up, front and back, left and right, top and bottom. So how do I find the area of a square? Well, it's x squared. So that's going to be radical v squared. Okay? And since there's 6 of them, the surface area is 6 cube root of v squared. Okay, so it's cube root of v times cube root of v, and there's 6 of them. So that comes out to be 6 cube root of v squared. Okay. So the final answer for the surface area, S for surface area, So you can write it like this, 6 times the cube root of v squared, or you can write 6 v to the 2/3. Both are okay. And that's my answer for 63. Okay. Okay, I wanted to show you 67 because that's harder. We're not here yet, but it's already there. 67. Somewhat involved. Okay, a manufacturer estimates the profit on producing X units is P of X is equal to 300X minus 2X squared. So 300X minus 2X squared. If you can't see that, I've got it written down in a second. And what is the average rate of change in the profit as the number of units changes from X to X plus H? Okay, so I'll work on that. And then B asks for the average rate of change if you're going from 25 to 50. And we said skip C and D. Okay, so I'm going to do A and B, skip C and D, and I'll give you everything you need. All right, so if you couldn't see the text, I've got it all here. Okay, so the profit function is 300X minus 2X squared. What's the average rate of change when you go from X to X plus H? It's really just Y2 minus Y1 divided by X2 minus X1. Okay, so M is Y2 minus Y1 over X2 minus X1, or average rate of change. So average rate of change is basically slope. Okay, symbolically, it's P of X plus H minus P of X. So I plug in X plus H, I plug in X, subtract. That's like Y2 minus Y1. Okay, so I'll symbolize that. I'll sneak in a little Y2 minus Y1, and this is X2 minus X1. Okay, now when you get to calculus, you'll see this expression quite a bit. You see a lot of that. Okay, so P of X plus H minus P of X, because I'm going from X to X plus H, and you divide it by X plus H minus X. Okay, that's Y2 minus Y1 divided by X2 minus X1, or the slope. So the slope of the line that would join these 2 points is the average rate of change. Okay, the bottom is easy. What's X plus H minus X? Well, X cancels out, so you just have an H on the bottom. The hard part is the top. Okay, so I have P of X plus H minus P of X. Well, minus P of X just means minus the original. So there's minus P of X, 300X minus 2X squared. Okay, so that's the easier part, 300X minus 2X squared. The hard part is P of X plus H. So like any other function, right here, you have to pretend you erase it, put parentheses X plus H. Same thing here, erase the x, put parentheses, x plus h. So 300 parentheses x plus h minus 2 parentheses x plus h squared. So all of this mess right over here is my p of x plus h minus, this is p of x, this is just the original function in parentheses, and I'm dividing the whole mess by h. Okay, and then I have some heavy duty algebra after that. Okay, so that's considered the average rate of change from x to x plus h. Okay, I know what they're doing. They're setting you up for calculus. When you guys get to calculus, you'll see a lot of this stuff. So they're introducing it to you now, which is why we're in pre-calculus. Pre-calculus is supposed to get you ready for calculus, right? Okay, so now all this messy algebra, distribute 300x plus 300h, right? Minus 2. Then I have to square x plus h. So x plus h squared is this by formula, right? X squared plus 2xh plus h squared is all this stuff. Okay, so that is this parentheses here squared is that. And minus 300x minus a minus, so plus 2x squared. And now I'm going to distribute the negative 2. So leave that alone, and then negative 2 times x squared, negative 2 times 2xh, negative 2 times h squared. And leave that alone, Okay, so I finally have all of this, and I get some cancellations, right? That's going to cancel that. That's going to cancel that. So I have 3 terms left. That one, and that one. What do these 3, that one, and that one, have in common? They all have an h. And that's convenient because that means there's going to be an h in the bottom. That will cancel out. So factor out the h. That's going to be 300 minus 4x minus 2h. If I take an h from here, there's still one left over. So h paren 300 minus 4x minus 2h. And now the h's cancel out. So this is what I have. 300 minus 4x minus 2h. Okay, now for part B, it asks for the average rate of change from 25 to 50. Okay, so I'll just hit the highlights of that. It means you plug in 50, subtract whatever you get when you plug in 25, and you divide it by 50 minus 25. This is like y2 minus y1, x2 minus x1. Okay, so you plug in 50 and 25 back into the original. So 50 goes here, 50 goes there. 25 goes there, 25 goes there. To save you time, you can punch it in your calculator on your own, but I've got the calculations here. So P of 50, plug in 50, 300 times 50, minus 2 times 50 squared, from way back here, comes out to be 10,000. Plug in 25, same function, except now I'm plugging in 25. So 300 times 25 minus 2 times 25 squared comes out to be 6250. Okay, so that goes right here, right? P of 50, I now know is 10,000. P of 25, I know is 6250. Divided by 50 minus 25. Okay, punch it in a calculator. 3750 divided by 25, and the answer comes out to be 150, it looks like. Okay, so 150, and there we go. Okay, that's it for that one. So I'm done with the section. I was going to introduce a little bit of what's happening next time just to make things easier for me, and then I'll give you the quiz. Okay. So next time we're going to start 1.7. So I'm done with what I need for 1.6. 1.7 is a review of linear functions, straight lines. So hopefully this is not too bad. Page 55. At the bottom, and I don't really know why the book does this. it says linear function y equals f of x, ax plus b. You should really think of it as mx plus b. I mean, that's the way it is in most books, right? So technically they're correct. You can have any constant, but since we already know that constant is slope, m, okay, make it mx plus b, right? Mx plus b. So you know y equals mx plus b, or f of x equals mx plus b, linear function. And some things to remember. Formula for slope. If you have 2 points, x1, y1, x2, y2, page 56, this is how you find the slope, right? You should be comfortable with that. y2 minus y1 divided by x2 minus x1. In fact, I did a lot of that already. Okay, then the point slope form of a line. If you're given a point, x1, y1, and a slope m, use this. Y minus y1 equals m times x minus x1. Okay, you can put that in your cheat sheet if you wish. Y minus y1 equals m times x minus x1. Okay, top of 57. All of this should be reviewed, hopefully. Okay, if you have a positive slope, then the graph increases, right? That means the graph goes something like this. And the larger the positive slope, the faster the values of y increase. So a positive slope, so if you have a big number, it's more like that. If the slope is positive but not so big, then it would be something like that. Okay, negative slope, that means the graph decreases. That means it's going down like that, right? Okay, and once again, negative 10, negative 30, negative 80, it's much, much more steep. Negative a half, negative a third, it's not as steep. It would be something like that, right? A horizontal line has zero slope, or slope of 0 for a horizontal line. A vertical line has no slope. We often say undefined slope, okay? The reason for that is if you plug into the formula, you get a 0 on the bottom, and we know we're never allowed to do that. Okay, so they give you some lines here. You might not be able to see it properly, but that's okay. So this says y equals x, y equals 2x, y equals 3x. So they're all positive slope. And notice slope of 1, 2, 3, it gets steeper. And they're giving you here, whoops, y equals negative x, negative 2x, negative 3x. So they're all decreasing, right? They're all going like that, okay? And negative 2x is steeper and negative 3x is steeper still. And this is negative a half x, so it's not quite as steep, but still negative. All right. Oh, here they actually have the y equals mx plus b. Okay, you knew that. Slope, y-intercept, right? Never mind about that. That's extra. So y equals mx plus b. Okay. And extra things, page 59. Parallel and perpendicular lines. Okay, so if you have two lines, they call it L1 and L2. And you have slopes M1 and M2. Okay, the lines are parallel if and only if M1 equals M2. So if you have two lines that are parallel, they have the same slope, right? So they both have a slope of 7, or they both have a slope of -3 or whatever. Okay, lines L1 and L2 are perpendicular if and only if M1 times M2 equals -1. Okay, I'm going to write something extra here. If I divide, I get M1 equals -1 over M2. This says the same thing. M1 equals -1 times divided by M2. These are called negative reciprocals. Negative reciprocals. They are negative reciprocals of each other. So that means you flip the fraction and change the sign, and that will lead to perpendicular lines. Okay. I won't show you any examples today. I'm saving that for next time, but I just wanted to give that to you. And let's see. Yeah, I think that's all that I need. So put that in code storage. Monday, I'll get started with 1.7, but I'm done for now. So let's get ready for the quiz. Okay. So I will get the quiz right now. And you can get out your cell phone maybe and take a picture. You can write it, I guess, or you can do a screenshot. Okay, so you test for the 3 symmetries, x-axis, y-axis, and origin symmetry. Okay, so look up in your notes how to do that, right? So number 1 says x squared plus y squared equals 1. X squared plus y squared equals 1. Number 2, y equals absolute value of x. Y equals absolute value of x. Okay, so test all the symmetries. And everybody is responsible for both problems. Okay, so even though you're going to work in your group, I'll put you in your groups in a second, but everybody is responsible for their own, and I'll grade you individually, not as a group. Okay, so I'll give you a few more seconds for that. X squared plus y squared equals 1, and y equals absolute value of x. So each problem has 3 parts. Okay, so number 1, test for x-axis symmetry, then test for y-axis symmetry, and test for origin symmetry. Look back in your notes if you didn't get that, and do the same thing for number 2. Okay, is this enough time? Everybody got that? Okay, I'm still recording, so you can look at the video a little bit later also. Okay, so start working on it on your own for now. It'll take me a few seconds to set up your breakout rooms. So I'm going to stop the share and stop recording.